Hello, what's going on, everybody? Okay, well, I wanted to start off by saying that this is a pulse motor with one trifilar coil, which now has a primary drive and then a second primary drive. They're in parallel with their own power sources, but they're inside the same coil. So we'll see how that goes. You check what this is at, the power supply for coil, call it coil number one. It'll be at 12.5. I'll turn this one off because it's got a switch. Now I got 9-volt battery connectors on their way. And we're going to finish putting together my top counter rotator. Show you how much I got done. You just need the battery connectors. And some batteries. 12 volts. This is the 20 gauge strand. Got 12 volts going in it. Let's check it out. So this is what used to be the secondary part of the equation, and then I just took out the extension cord and put in the power supply. And that's pretty much what's going on here. Now I'll turn on the main drive. Yeah, I think that's cool, man. That's awesome. All happening in that little space right there. It's cool, man. That's cool. Ah, yes. $24, $25, $2,500. $2,550. We'll cut off the main drive. There's no way to really cut this off except to turn off the power or unclip it. So I just turn it down like the knob. Here, we'll try the hood. Look up here. Hang over here. That'll work. All right. Let me go get it. Counter rotator. I'll be right back. All right, so this is it. Make sure I'm getting this in the camera because I'm trying a different height for the camera. Let's turn it like that. All right, so basic pulse motor principles, except we're putting it in a plate that will spin like a top. It will spin like that. And hopefully, when this turns on, it'll spin in the opposite direction that you spun the top, which will cause the top to spin faster and maintain and probably equalize. At least that's what I'm hoping. Now I'm thinking that I'm going to need to put another coil in at 180 degrees to balance it a little bit more. And I know that sounds weird. It sounds like I should put two more coils in to balance it out, and I would. And maybe I will end up doing that. I don't know. I'm going to start with two though, just to try and balance the weight of the stator here. Yeah, that should be interesting. But it does work. It does spin. I mean, it doesn't run, but I mean, it spins at least. Nothing gets in the way. That's going to be real important and come into play. All I got to do is put the batteries in, connect one end of the battery to the collector, and the other end of the battery to this wire right here, and then connect this wire, which is a trigger coil, to the same common ground, and it should be functional with the one coil. But then when we get into doing two coils, probably in series, unless we're going to do a multi, we might end up needing more power. So we might end up doing a two transistor deal here with one for each coil. And that, right now is trial and error. I think I'm going to get this to go on the first try, though. Not maybe counter rotate, but the rotor is going to spin at least. And then what I would do is get the rotor spinning and then try and get this on a surface with as little pressure as possible and get it to go. Like hold it while it's going just to make sure that it stays up. That's what I would do. I mean, and then if I can just get it to go, that would be awesome. If that's what I got to do to get it to go, that's what I'm going to do. That's going to be sweet, though. I just decided to go ahead and say, hey, man, time to get doing this. I'm going to try and make it as simple as possible, considering I don't have a lot of space in here. But I do think I can fit another coil in there, if not two. It's going to be awesome. Man, I can't wait. And it should be here between 5 and 10 today. Yes, I love my family. uh, This is called the living room. Well, now it's called my laboratory. Hello, hello, Nimish. Hi, Nimish. Do I know you? I think I do. Hi, hi. Uh, uh, yeah, let me think here. Usually I hook it up to the TV so I can see what everybody's saying, but the TV tends to turn off on its own, and then sometimes it'll shut down my stream when it shuts down. So I don't do that anymore. Maybe I'm an artist. I got like 4 or 5 times more paintings than I do pulse motors. It does not run without electricity stably. It and it well, it's 3 magnets per disc, so it couples sparingly. It's got to be going at a certain speed. All I can say about it is it likes what it likes. So I got all 3 of these coils hooked up. Those are going to sync up pretty easily. And you got your LEDs lighting up over here and everything. Maybe they're not in the picture. I'll have to move it. Some of them need a little boost. And this is definitely a whip. It's work in progress. And the magnets are a little loose too, so it gets really noisy. But right now, it's just for the motion. When it gets going all the way around and in the right position, I think it's going to be really, really awesome. But, with things being as they are, it's going to be a while before I even get a chance to experience it for myself. And then, like I was explaining over here, let me move the camera one more time. I used to have a camera person. My brother wanted to be my camera guy. And he was really good at it. But he got busy doing other things. All right, so this coil is a tri-filar coil. It's got a 32 gauge trigger that triggers both the 18 gauge circuit and the 20 gauge circuit at the same time. So it's simultaneous, but they have different power supplies, so you can turn them on at different times. They just hit at the same time because the trigger's trained. All right, so I'm going to turn this on 12. Get it going with the 20 gauge strand at 12 volts, like a little primer. You know what I mean? I think I know what's going on right now, and I think it's great. Oh, man. All right, so this is a 20 gauge strand, secondary drive. All right, now let's turn on the primary drive, 18 gauges, 1mm wire. I don't know if you can hear that or not, but it's definitely revving up. Like unbelievable. With them both going at the same time, how quickly it revs up. 2100. $25. Woo! I bet we can get it going up to 300 or 3,000. But I'm not going to do that. 2,600. I'm definitely going to, excuse me, print a plate for the top of that disc before I go anywhere above 20 where it just was. But the way I had it set up before, the secondary drive would be on during running, but then it would stay on after I shut it off. So after I cut the power, the other way I had it set up would make it spin for about 2 more minutes after shutting it down. Not a big deal, but definitely a difference between having it and not having it. And then the inertia is not a lot in this disc. It's not greeny over there. That disc is solid plastic, and it has a lot of inertia, like flywheel capability. It'll like it'll like make my fingers raw trying to stop it. This one's nice and light, and I think that's why we're getting the RPMs we're getting out of it. I think if I left it running, we could get 3,000 easy. Well, maybe. We might have to put a little bit more voltage into both strands to get there, but just a little bit, like 14 and 14, probably get us there. But yeah, this right here is going to be just neat. It's going to be awesome. See, you got your pointy bottom, so you got your top, and then I'm just going to hold it while we spin the rotor. Or we're going to spin it like this. We're going to spin the stator. Try and get the rotor started that way. Oh man, trying to balance the weight on this thing, and it's going to be a challenge, no doubt. I'm going to just throw it together the first time. I'm going to do it with one coil, and then I'm going to have 2 9-volt batteries in series for 18 volts right here. And then that should be good, man. That should be great. Yeah, a lot more playing around with the camera because the angle is so different. I'm gonna back it up a little bit. Try and get more of that in there. All right. Man, the anticipation of waiting for what you need to finish the project is always like reminds me of the time when the hyenas in The Lion King, they're all like, Mufasa. These sync up pretty good. And having a flywheel in the middle makes it all the easier. So instead of going up onto the second level, just keep it all on the first level right now. It's choppy. And it's because there's only 3 magnets in there and they're a little loose. But once it gets going, the sound pretty much disappears if they both sync up. I love how responsive the circuit is. You can kind of see it with the lights over here. Let me move it over here. Look at how responsive the circuit is. Because when it'll stop. All right. Yeah, the magnets are really loose. But it's starting to sync right now. See, so I don't think 3 magnets is going to cut it. But I only did it 3 so I could get 4 discs out of the 12 magnets that I have. So, if I get more magnets, all this will change. Probably. That one likes to go. This one's having some trouble. Yeah, this one got going over here. I'm wondering if I change the magnets out of this one into the other rotor like this, if it would work. I don't know if it's the rotor or what. Oh, see now. Those are synced up. Okay. Yeah. That's what the difference is. Can't really do it like that with three. They all got to be pushing. Can't have anything pulling because it's uneven. I mean, it's balanced, but it's uneven at the same time. So, I'm just swapping them from whatever they were to the opposite of it so that they get pushed instead of pulled. I know it was working really good, but the other one wasn't working because this one was being pulled. At least that's what I think because it was working before. And that's the only difference. All right, let's give it another go. And it should be a little less noisy, I'm hoping. Let's see if I'm right about that. Oh, wow. Yeah, that's not working anymore, is it? Forgot to hook up an alternative power supply to that coil over there. Wow, that's a lot of torque. I just felt that. There it goes. And see, nice and quiet, nice and synced up on both sides. It's so much better when everything is doing what it's supposed to do. And this is with this north, north, north on all of this. That works so much better. It's amazing. But that's just because there's only three magnets. Like if I had 6 per disc, then I would do north, south, north, south. And it would be more stable, I would imagine. And then yeah, I can put all different kinds of coils and dynamos and whatever I want to put on here to generate. I've already got some things generating, but I'm not aiming to generate with this. I'm just aiming to at least get one staircase to go all the way around to the 180 degrees of where it started. And the only way you can do that is to go up. You gotta go up. But I don't know. I mean, it's just I took the cheap way. I bought a pegboard, and the pegboard has determined pretty much everything that I've done so far with multiple poles in it. Makes sense, right? I'm thinking that I might need to make my own base and, just put a lot more thought into it. I mean, it's working out okay. I mean, it's obviously doing what it's supposed to do right now, but when you get going on the second level, you start losing like half the speed per level you go up. We want to reduce that, uh, either by changing this magnet strength or whatever, however we're going to do it. But this level and this level got to interact a little bit better than they're doing, and so on and so forth. I think, I mean, I had it going up to here, and it looks pretty okay. Uh, but it's really slow up here. You got to jump start it a lot. So it's going to go here, and we could even do this, and this would be really cool. Make this the first elevated level. So this disc and this disc automatically from the beginning get go, they're interacting on a different vertical plane. And that might even be cooler than what I'm trying to do. So it's more like a tornado than it is like a helix or hourglass. It's supposed to be, a helix and have the thing go around the center like that. But I don't know. Uh, I haven't even looked at a picture of a helix in like 20 years. It reminded me of one, but then it's like more like an hourglass, the legs of an hourglass. It'd be like that. Lots of different representations, two spiral staircases going around the middle. They're all pretty much the representation of, this is pretty much a representation of all that. Yeah, let's put it that way. Oh man. Here, let's bust out the contactless dynamos real quick. I've been thinking about how I can set them up to, interact with the power supply, or you know, give a boost to the wheel here. I love how smooth that is when everything's working right. Man, that one layer is always dynamite. All right. And I guess the faster it goes, the more energy is produced. Woo! Look at that. So I was thinking about putting this into the bridge rectifier and then sending that into the secondary. $2,700. So cool, man. So cool. So I got two of them. So I was thinking I'd either hook them both up to the same bridge rectifier, make it simple, or give them each their own bridge rectifier. My little halogen lights are lighting up. That's awesome. It takes 13 volts to light them up. Yay. Heck yeah, man. What's up, bro? I build everything because I want to. And that one over there, the copper one on the end of the table, is internal power supply. Runs on its own battery and is completely untethered. And an electrolyte soaked cotton isn't going to give me enough power. And it'll work for a while, but it's not, that won't do what that just did. I want to build one of those coils though. It's like a tri-filer coil with aluminum strand and then an insulated strand with electrolytes. And it kind of powers itself, man. It does its own thing. It's not that powerful. You gotta have really good bearings to make it work really good. It will go for about 15 days, man. You've seen it on Daniel's Inventions. He's got the lowdown on that whole thing, man. It's pretty awesome. So you got my LEDs lighting up, and since the center disc is pushing two other discs, you got quite a load when you can see them blinking. But then again, I took the power from that coil right there and I put it into the secondary of this one. So I have two power supplies running this one. And all I got to do is take the clips and put them back onto this. All right, I did not know my mic had died. Lucky I got a spare. It's all right. We really haven't covered that much. I hope. Huh? All right. I think I should separate those legs a little bit because it does decide to flop around. Okay, now we need a light. I got one. I know where one is. Now we can either go another halogen or we can go neon light bulb. A 90 volt neon light bulb. They have pretty much the same effect, except this one's probably going to light up a lot more than the other ones will. All right. Come on. Gotta be one of you around here somewhere that I'm not using. Oh, here's one. Hopefully it'll work. And here's another one. I'm gonna grab that too. All right, so we'll hook the light up. Emitter to collector, or collector to emitter. Now here's the question. Does this transistor get grounded? I mean, does the trigger coil get grounded to the bridge rectifier or to the power supply of this transistor? I'll be right back. All right. So I'm going to hook up, as soon as I find another clip, the trigger coil to the ground for the power supply. Wow. Huh. I need one more clip, and I don't think I have one. There it is. Oh my God, yes. Woo! It's the last one anywhere. It's meant to be. Meant to be, ladies and gentlemen. This is meant to be. All right. Here goes nothing. Power to 100% alternative means. Secondary coil here. I'm going to turn it down. Now, because there's no current, it's naturally going to get a lot slower than it was. But you gotta use the scope here of voltage input, and then there's very little current, but there is current. We're about 4.1 volts right now of input from the secondary coil, or to the secondary coil from the generator coil. Now when it turns on, which is the primary power, it gets a boost from the primary transistor along the extension here to the transistor of the secondary coil. So right now, two coils are working. Woo! Yeah, that was pulling about 1.5 amps on that, both transistors. Oh, wow. $2,200. $2,500. You know, that's weird because well, it's not that weird. I mean, it's coming right off of the bridge rectifier. This reading right here, 150 milliamps. The coil is tiny, man. It's a tiny coil. It's about 666 turns of 4 different strands. You got 26, 28, 30, and 32. Hand wound. Counterclockwise, actually. So it's like this. Still got about 3 volts. So I know that that trigger is firing, and I know that like now 1.9 volts is going into the transistor, which isn't going to, help it along any. And then you get down to like 1.5 or where it is right now, and it's more like the lower voltages are worth. It's like more viable right now but anything below this point just isn't viable in the grand scheme of things anyway. So it's like, yeah, it's cool. I mean, you can kind of hear it. I hear that one over there, sure. But I'd say no, not too tremendously awesome, but I think it's still working because I know that that trigger is still firing. I've run it by itself before, so I know that it's still working. 0 up 100 milliamps at 25 volts. That's big red over here. This big red coil. Man, it's a great coil. $20 volts. 20 volts. Oh my God, what's going to happen? Somebody did not like that increased voltage on the primary. So it's either this one or the new one. Some stinks. Yeah. This one is good. It's awesome, man. I can't get enough of it. Although I do think it would work better without all the extra coils. Just take it all out and run with the one. Call it the one and be good. All right, I'm going to get this and walk around a little bit. Yes, testing. 1, 2, 3, testing. Yep, I'm testing my tri-filer coil and the best way to use it. Right now I have 2 parallel drives hooked up, and then I have a third drive that's running, should be running right now, and that's how much voltage it has. The capacitance of the motor, so it'll prolong that experience. Is my audio back? I'm pretty sure it's back. My turntables. All right, so this is the basic circuit that we're looking at right here. You got from left to right is base, collector, emitter. And those are the connections. You got 1, 2, 3. Bada boom. And over here, 1, 2, 3. Actually, you get a third one in the middle here because we're this white cord is an extension and is powering this one right here. So it's getting this power from 2 places. 1, the bridge rectifier, and 2, the extension from that transistor. And then in an extension, you get virtually the same amount as you put in. And it just scoots along. So you hear that? That high pitch? Boom, I love it. And then the 2 of them combined makes a totally different sound. Yeah, it's a brushless DC motor. It's working with these 2 power supplies currently. This bench power supply and this buck converter over here are powering the 2 circuits. All right, cool. Because on some of my videos with this mic, you can't hear it. So it's a 20 gauge and a 1 millimeter coil, about 666 turns. And then a 32 gauge trigger strand wound in there as well. I'm telling you though, I'm going to get my 9-volt battery connectors, and then the copper thing on the end there is going to be done pretty much. See all these LEDs over here? They're being lit by the extension, well, by the tri-filer, the center, the third strand. They're being all lit by the third strand. It's just the interaction between the trigger coil and the drive strand creates all this electricity. And then this is the output for the circuit, which is right here. Energy store. Yeah, this one's going to be all self-powered. It should. What it's supposed to do is it's supposed to be like a top that you spin, except this one, once it gets spinning, it'll spin faster and faster. And it'll get going pretty well. I mean, of course, it's going to have a ceiling of how fast it can get and how fast it can get there because it's only got that one coil. But I'm willing to bet it's going to be pretty outrageous. Actually, it's going to be dope. None of this stuff is powering itself. I mean, this rotor right here is about as good as I can get it. It definitely is moving on its own volition right now. That's weird. That's really weird. Yeah, I got a tach meter. Hold on though. My second gear is not working. Huh. I wonder what's going on. I hope it's not the transistor. Wow. So I'm thinking that means I should turn this off. At least that circuit anyway. This is just for me moving it with my hand. Let me do this again. Yeah, I'll give you a tach reading real quick. But look at that. That's definitely like working, kind of. But yeah, let's turn it on. Yeah, that one on the end though is simple as pie, man. It's so easy and it's simple. I gotta figure out what's going on with the circuit though. So there's supposed to be two distinctive beeps, and this one definitely is not doing its thing. Hmm. It's gotta read a transistor. Hmm. All right. Yeah, it's about 1500 right there, but it's not going to work without the second strand functioning. I don't even know what happened. So if I don't know what happened, I figure it's got to be the transistor. Ball bearings. They're half an inch and a quarter inch bore. I'm getting some ceramic ones coming in the mail. Uh, 6.35 millimeters. Yeah, that stinks. I mean, I got a replacement right here, but I don't want to mess with it. Blah. Whatever. Um, I get a lot of my stuff from Amazon. So, but I think I don't know what's going on with Amazon right now. I still use Amazon. I can't wait for my battery connectors to get here because there it is. You turn in the wheel a little bit. You got your transistor. I got my trigger coil in the base. I got my drive coil in the emitter. When I get the batteries, I'm going to put the other end of the coil into the one end of the battery. And I'm going to put uh, the other end of the battery into the collector. And then it'll be done. I'm making it an 18-volt system. It's going to rip, man. I don't know if it necessarily would be a child's toy. Yeah, I'm gonna have to figure this out. I'm probably gonna have to change out the transistor on this middle one right here. But number one still works. So right now, both of the coils are on. Something's rubbing. And what I mean by both coils, I mean like the main coil and then the secondary coil, which is over here. They're both on right now. Yeah, it's not really getting that fast. Dang it. $1,800. 1,900. That's 12 volts in. They all have their own trigger, so not really. They're not aligned. It's pretty close, actually. I'd say it's about 120, about right up in here. Yeah, they're aligned. Now the generator coil I just threw under there because it doesn't need to be anywhere special. I put it as close to the generator to the drive coil as possible. Maybe pick up some radiant energy from the coil. $2,400. That's not bad. Now it's an axial flux design. Whew. Yeah, that's hot. I know that's getting more torque than it being just just chilling off. It's not the same. All right. But it doesn't have any current, so it's not doesn't like have any torque to it. It's just not the same. It's very weak, but it's definitely there. So I think like this one here is a 5/8 with a 1/4 inch in the middle. 1/4 inch. All my shafts are 1/4 inch because the base here has 1/4 inch holes in it. Just kind of fit together. But I think a stronger shaft and a sturdier base would definitely make for way more DPR, not DPS, but RPMs. It's virtually the same thing. DPS and RPMs. Anybody want to argue about that? Mm. shoot. All right, we got one transistor right here that we might just be able to reinstitute if it's not blown. All right, there it is, transferred. Let's see if it works. Nope. Yeah, I don't know. That's the thing. I'll have to work that out, man. That's a bummer, though. We still can get up to 2400 without it, though. It's pretty awesome. All right, so our sync up motor is working pretty well with just the one coil working it. It's working on 24 volts right now and 0.1 amp or 100 milliamps. That's awesome. And it's kind of like a step spiral staircase. Gonna go up, link up with that one, and then this one's gonna go up on this side and link up with this pole. So in the end, or in the end of the first phase, it's gonna be 2 discs on this pole. Well, yeah, that might be true. Not sure if that matters in this instance. Now over here, you're pulling about an amp per strand, so you're pulling them almost 2 amps. With this one, you don't need all that. It's just moving some disc. Yeah, I can get it even less than that, even less than 100 milliamps. What I need to do here is there's a 20 gauge strand in here and there's a 22 gauge strand in here. The 22 gauge strand is hooked up to the LEDs. What I do is I take the 20 gauge strand and put it in series with the 22 gauge strand, and then the amp draw is going to be like 20 milliamps, maybe less. This is a sculpture, man. This is art. This has nothing to do with efficiency or generating electricity or anything like that. I'm just going to make a bunch of discs. I'm going to break it down for you. 1, 2, 3, 4, 5 discs per section per side. So there's going to be 10 discs right here. Okay. And I know you can't really see it just yet, but there's going to be 10 discs, and they're all going to be moving. Yeah, I know how it's complicated because you're actually using a pulse motor in the center to move it by itself, kind of. And it's going to have an external power source because it's the most reliable. Um, but it's all going to be it's all going to be moving. And that in and of itself is going to be freaking fantastic for engineers and artists alike. That's going to be dope if it even happens. Because, 10 discs, look at how much magnetic coupling is going on, man. There's like a whole inch there on both sides. And then, of course, when you go vertical with it, it's going to get interesting. It's going to get really interesting. But, I've tried it other times. I've used 12 north, south on 12 north, south, and that moves really, really well. It moves very well. And there's barely any skipping or anything like that. 12 on 12 is really good. This is 3 on 3 on 3. And it's good too. All facing north. They're all north facing because it's only 3 magnets. And they're all facing north. So it's pushing. It's a push mechanism. It doesn't, there's no pulling going on here. Yeah, I was thinking the bearings would have to be good and the weight would have to be right too. Because that one in the middle weighs a lot. And therefore it's got flywheel capabilities. And that's why I put it in the middle. Yeah, but the bearings got to be true and they got to be greasy as hell, man. They got to be, and I don't mean greasy, I just mean like really smooth. But I've gotten it up to the 4th level and it was all moving. I got a short of that. And I was also thinking, and I'll show you real quick, maybe. Yeah, I think I can do this. I'm gonna put the camera up and I'm gonna move these up to the next level where they're at. And turn the power off. Let's see if we can get them to couple right off the bat. I need a wrench, so yeah, that's very torque-ish right there. Okay. Say that'll be a good level. Make sure. Is it too high, do you think? Maybe a little too high. Now I'm willing to wager these bearings are not good enough. And the orientation of the magnets might not be good enough either. Those bearings are a little better. All right, now let's see. They're too high or what? Voila. And that's with 3. We can make it a lot more like stable, but I only have a certain amount of magnets, and 3 made it so I could use more discs. So I'm thinking ceramic bearings are going to be the best solution for half of this. And then it would be more like a tornado. Just kind of twist down or twist up like that. All right, that's kind of annoying right now, so I'm gonna cut it back. If anybody's got any ideas on how to orient them, maybe change the orientation of the cubes to make this work better. But I think this is as good as it's gonna get like this with the 3 magnets anyway. Maybe put a piece of tape around each magnet. Because all that knocking is just the magnet being too small for the hole that it's in. But it works, kind of. That's awesome. Huh. Hmm. Hmm. It is hooked up. There it is. This is the one that got smoky, so probably has a little bit to do with it. One of those clips probably isn't good anymore, which would be bad. All right, well, I got some things I got to fix. I can't wait for my connectors, my 9-volt connectors to get here. That's going to be so cool when that gets done. I might have to hold it up to get it going, but I think once it gets going, it should stand on its own. Maybe put a pillow block on the top here and then spin it. Right now it's pretty lopsided with the weight. All right, well, thank you all for coming by. Really appreciate everybody who comes in. Even when you don't have clever stuff to say, it's all good. I appreciate all of you. All right. Well, I'm going to call it for right now. You all have a great day. I need to eat. So, but yeah, let me recap real quick before I go. All right, so we got magnetic sculpture in the middle, all north facing outwards. I was wondering if there was maybe a better orientation for them to be interacting with the top, with the vertical. Yeah, I think honestly, like since they're cube magnets, I think north and south should be facing like so. So when it moves around, north will be pushing more so than it is now. But in order to get this to work the right way, north has got to hit north and south has got to hit south of the adjacent disk. Oh, it was working pretty good like that. Look at that. That's pretty good. Anyway, I think it might be as good as it's going to get the way it is. It's just I got to put some tape around each magnet so it fills in the little air gap it has. Be a little less noisy. But, I got to be cost conscientious and I've got to like make it so it'll work. So, yeah, I got a drawing kind of what it's going to look like from the top. So you got your counterclockwise rotations starting from either side, vertical view. And then it's going to go up 4 or 5 layers. Let's see here. 1, 2, 3, 4, 5. Just like they are right here. Then the fifth disc will end on top of the first disc. So like right here. I think it'll be like, man, if I can get enough coupling to happen, that'll be awesome. Like just enough torque and enough coupling to happen. Doesn't even have to move very fast. It just has to move all the discs. I think bearings are going to be one issue. Weight's going to be another issue. But yeah, I think it's going to be really cool. And I need to get this drive fixed. I might need to get more clips. Just buy a whole nother load of clips. Get the big ones that aren't all magnetic and stuff. And they clip well. It'll be awesome. So there it is. I'm gonna call it the 1, 2, 3. 1, 2, 3 circuit right here. 1 for the base, 2 for the collector, and 3 for the emitter. There's the standard circuit. 1, 2, 3. And then you get 1, 3, 3 when you're doing an extension. Awesome. And the reason that is 1, 2, 3 is because you got a light. Got a light of neither a neon light or a halogen bulb. And it's amazing. I mean, look into my mind right here. It's all kinds of wood twisted like that. But so this is going to be a Triumph. It's going to be an 18-volt system. I don't know. I don't know. We'll see what's going on with that. And then we're doing here. I'm gonna do some contactless dynamo real fast. These things are awesome. You want to see that? I want to see that. Wow, that was sick. That sounds better. Scraping against something. So cool, man. And then we could take the light off and plug that in to something else. It's gonna be sweet. But I guess there's a few things that I could brush up on, like all the ends here could be tightened up a little bit. I keep on saying that though. Never really get around to doing it because I don't have an optimal way to do it. What's up, kitty? Meow. All right. Well, yeah, man, I can barely think. I got to eat something. All right. Well, thank you all very much. I'll keep learning about this stuff. Keep bringing you different types of stuff. It's all pretty much the same thing, though. It's DC brushless motors. I haven't even gotten in really into AC or anything. I need a Varic AC transformer before I even get started with AC, really. So all this is DC brushless motors, all different kinds. Virtually the same concept, though. I make my own coils, so each one of these I like to test coils. I like to test them out. And like this one, like shorted, this second strand shorted out somehow. I don't know how it happened. I hope it didn't get melt like the enamel. That would suck because it was during a high voltage test. And like this one right here is 26 gauge and 16 gauge. So it's got a 26 gauge trigger strand, and then it's got 16 gauge drive, which is really neat. It pounds pretty hard, even with like 250 turns. Now that red coil right there is like pretty. It's thick. It's wrapped a certain way. It's wrapped in I think repulsion mode. So it goes up 100 turns, and then it goes back in 3 turns, up 100 turns, back in 3 turns. So it's all kind of going the same way. Buddy of mine, 007, taught me how to wrap coil like that. It's pretty cool how it works out. And it all depends on what you're going to do with that coil, honestly. What you should wrap it for, or how you should wrap it. Um, oh, look at my sphere, man. We should do something with that real quick. Yeah, I don't know how I'm going to manage to do this. Boom. Whoa. Yeah, I don't know. That opened it up the floodgates. Really, that wasn't good. Anyway, I need both my hands to make that work. All right, but man, That's all it takes is just a twist, and then. But I got to be able to hold that bowl. Oh man, that would be fun. But like I said, I got to get something to eat. So I don't know. Maybe I should kind of leave the stream running and go get some food. I mean, would that be even a thing? I don't know. Because all I want to do is show you that sphere, and then I want to go. Maybe next time. We'll do it next time. All right. Thank you very much. Peace out. Have a great night. Please subscribe. Hit the like button. Peace out.